Alright, today I'm going to show you how to get the maximum and minimum from a contained region. So right here I have two different problems. I'm going to do this one first. When we're doing this, we're going to ignore this piece at the beginning. So what we're looking for is the contained region, meaning that when I put this system of inequalities together, there's going to be an area where all of my safe zone is contained inside of the danger zone. So I'm going to graph these just like I would before. On the first graph, I have an x-intercept of 4 and a slope of 3. So I'm going to go up 3 and over 1. It's or equals 2, so it gives me a solid line. And it says greater than, so I shade above. The second one has a y-intercept of 10 and a slope of -3, so I'm going to go down 3 and to the right 1. It has or equals 2, so it's got a solid line. It says less than, so I'm going to shade down. So right now with these two, the only safe zone is in here. The last one has a y-intercept of 10 and a slope of 6, so I'm going to go up 6. Well, I'm going to go down and to the left. Has or equals 2, so it's a solid line. And it says less than, so I'm shading over here. So the region that's shaded for all three is this little triangle in here. Now what I'm looking for are the vertices. Vertices are the points at the edge of the triangle. So I'm looking for these three, okay? I like to write my inequalities as equations next to the line to help me out. So I'm going to say this is y equals -3x plus 10. I'm going to say that this one is y equals 3x plus 4. And I'm going to say that this one is y equals 6x plus 10. So I'm looking for the points where they meet. This one's really obvious because they both have the same y-intercept. So that's a point at 0, 10. Because they both have the same y-intercept. That one was easy. This one right here was also easy because it was the movement when I did it. So it was exactly right. And it's at 1, 7. This one wasn't so easy because it wasn't exact. So what I need to do to figure this out is take the equation of this line and set it equal to the equation of the line that it meets, this line. No, it doesn't meet that line, just kidding. This line, it meets this line. So I'm going to go 3x plus 4 equals 6x plus 10. Subtract 3x. 4 equals 3x plus 10. Subtract 10. -6 equals 3x. Divide by 3. X equals -2. Now I have to figure out what the y is, so I plug that into one of the two equations, doesn't matter which one. Y equals 6 times -2 plus 10. Y equals -12 plus 10. Y equals -2. So this point right here is at -2, -2. Now what I'm going to do with those 3 points, the 3 points I just found, is I'm going to use this formula here to see which point gives me the maximum number, the highest number. So I'm going to plug in my x and y. So the first one was 0, 10, which is 0 plus 30, which is 30. Now I'm going to plug in the next one. I'm going to go -2, -2, whoops. 4 times -2 plus 3 times -2. -12 plus -6, -18. So far the 30 is the biggest. And I'm going to plug in the last one. 4 times 1, 3 times 7, 4 plus 21 equals 25. So the maximum value is 30. The maximum input, what I put in, was 0, 10. The minimum value is negative 18. The minimum input, what I put in, was negative 2, negative 2. I'm going to do that same thing with the second example. So I have a y-intercept of 3 on the first one, a slope of 1/3, so I go up 1 to the right 3. So or equals 2, so it gives me a solid line. And it says less than, so I shade below. Second one has a y-intercept of 6, a slope of negative 2/3, so I go down 2 to the right 3. It says or equals 2, so it gives me a solid line. And it says less than, so I shade below. Right now I'm just in this area. The last one has a y-intercept of 0 because there's nothing here. A slope of negative 1/6, so I go down 1 to the right 6. So or equals 2, so I make a solid line. And it says greater than, so I shade above. So the area is this triangle right here in the middle. This point was easy to find because it was 2 of my movements. It's at 3, 4. This one I don't know. This one I don't know. So this equation right here was y equals 1/3 x plus 3. This one right here was y is greater, well, I'm going to put it as equals for this, equals negative 1/6x. I set these two equal to each other. 1/3 x plus 3 equals negative 1/6x. I don't like dealing with the fraction, so I'm going to multiply everything by 6. 2x plus 18 equals negative 1x. I'm going to subtract the 2x. 18 equals negative 3x. Divide by negative 3. Negative 6 equals x. Plug that in to figure out what the y is. Y equals negative 1/6 times negative 6 equals 1. So this point right here is at, this point right here, sorry, is at, what was my x? X equals negative 6, y equals 1. Negative 6, 1. This point right here is from the equation y equals negative 1/6x. And this equation is y equals negative 2/3 x plus 6. Set those equal to each other. Negative 1/6x equals negative 2/3 x plus 6. Multiply by 6 to get rid of the fraction. Negative x equals negative 4x plus 36. Add the 4x. 3x equals 36. Divide by 3. X equals 12. Plug that in right here. Gives me y equals negative 2. So this point is at 12, negative 2. Now I'm going to take this and plug each of them in. So negative 3 times negative 6 plus 4 times 1. 18 plus 4 equals 22. Negative 3 times 3 plus 4 times 4. Negative 9 plus 16 equals 7. Negative 3 times 12 plus 4 times negative 2. Negative 36 minus 8, negative 44. This is going to be my minimum value. My minimum input was 12, negative 2. This is my maximum value. My maximum input was negative 6, 1. And that's what we're going to do today.